right, welcome to day 2 of transformations. We're going to take a look at reflections and rotations today. So let's get right into it. So a reflection is a transformation where we are going to take a point and we're going to move it to the other side of what's called the perpendicular bisector. Okay, and it's exactly the same distance away. So you kind of have a picture like a mirror, right? If this is my mirror and I am standing here, okay, then there's going to be a reflection of me on the other side, except you got to remember is that it kind of gets flipped around, right? So it is the same distance away from the mirror as I am, so this distance is the same, okay, on both sides, and this also is a 90-degree angle formed between the angle of me and like my reflection in the mirror. But if I were to raise my right hand in the mirror, remember that the actual image is putting their left hand up. So that's why it's kind of reversed. So what we want to keep in mind is two things. Number one, a reflection is we talked about isometry. We've used the word rigid motion. Okay, so it does create a congruent shape. All right, and two things. Then, because remember we talked about I put my right hand and the image's left hand goes up, that is its orientation. So for example, if you were to slide across the floor, when you stood up, your right arm is still where your right arm is. Your left arm is still where your left arm is. So your orientation of your body is still the same. But in a reflection, the orientation changes. It flips, it reverses. Meaning, if I was going to read the letters in the triangle, B, U, G, okay, I would have to go in the opposite direction to read B, U, G on a reflection. Okay, so the order of the vertices reverses. All right, so that's what happens. So there's two ways to do a reflection. Okay, you either know the rule, how does it affect the vertices, or you just know how to reflect something over a line. For our purposes, we're only going to be reflecting over vertical or horizontal lines. So the first one I'm going to do is a reflection in the x-axis. Now the notation for reflection is a lowercase r, sort of a bigger lowercase r, and then the subscript is the line you are reflecting over. So if I write r x-axis, okay, then I know that points ABC are going to become A prime, B prime, C prime. So the first thing I'm going to do is locate my quote-unquote mirror, right, which is this line, the x-axis right here. So all I'm going to do is count from each point to the line. So point B is 4 units above the line. So its image has to be the same distance on the other side of the line of reflection, other side of the mirror. So it's 4 units down. And I can put a point there, and that's where B prime is. Okay, so A is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 on the other side. And C, you can see, is right here. It's 5 units away. So I'm going to go 5 units on the other side. Once again, we started with a triangle, so we want to make sure we end up with a triangle. Okay, and we're going to get this shape back. Okay. So here's point B prime. We wrote in. Here's point B prime, A prime, and C prime. And so you can see, if I wanted to read this as ABC, I would have to go around to the left. But if I want to read it ABC, I have to go around to the right. So the orientation is just reversing. Okay. So which coordinates changed? So what we would say is this. What are the coordinates of this? So we can see A has coordinates, okay, and the original point is -3, 9. B has coordinates of -2, 4. And C has coordinates of of, looks like 1, 2, 3, 4, 5. And so after we do the reflection, okay, I end up with A prime, which has coordinates of -3, -9. So what changed there, right? It looks like just the 9 switched sides. So the y coordinate changes sides. Let's see if this holds for B prime. B prime is -2, -4, and it does. And so C prime, I don't have to look at the graph. I can automatically see that it should be 4, -5. So what changed, right? We would say the y coordinate. Okay, switch sides. We don't want to necessarily say became negative. Switch signs. Is that the sign change from, right? If it was positive becomes negative, negative would become positive. Okay, so with a general rule, we write capital R, or lowercase r, write a bigger one, and then x-axis, the reflection on the x-axis. All right, of triangle A, B, C, actually, time out, we're not going to do that. We're going to write the point xy, x comma y, so any point is going to become x comma -y. And so that's our rule for a reflection in the x-axis. All right, going down to number 2, what if we reflect in the y-axis? All right, so same thing here. I'm going to start from the point. I'm going to reflect it over the y-axis. So here we can see this is 1, 2, 3, 4, 5, 6, 7 points away. So it's got to be 7 points on the other side. So there's where A goes. Okay, C is going to go all the way over. And point B is on the mirror, basically. So this point is going to stay right where it is. If you touch the mirror, right, your finger and the reflections finger are on the same point. They don't actually move, right? So you say the distance between them is basically 0. So there's my triangle. There's A prime, C prime, and even though there's already a point there, we still have to name it. So we're going to call this B prime. So this point technically has 2 names, right? B and B prime, but it's just marking the location. And let's see how this changes. So point A, right, started with coordinates 1, 2, 3, 4, 5, 6, looks like 7, 9, and became A prime, which flipped over the other side. So that's -7, 9. Okay, so just the first coordinate, right, the x coordinate changed. So point B is 0, 1, 2, 3, 4, 5, 6. And so if we were to change the first number, right, switch the sign to 0, so it stays 0. So this doesn't switch, that makes sense, okay? And then point C, which has coordinates, looks like 8, 1, 2, 3, 4. We follow the same rule, we switch the first number, the x coordinate here, and we should get -8, 4, which does match our graph. And so what changed, right? So now we're going to say the x coordinate okay, change signs. And so the general rule would be our y-axis, and then the point xy becomes -xy. So in general, the easy way to remember this is whatever axis you flip over, right, you reflect over, you change the sign of the other letter. So if you reflect over the x, you change the sign of the y, and if you reflect over the y, you change the sign of the x. All right. And I believe that was the end of the first page. Just double check and make sure we didn't forget anything. It looks like we're good. Let's go to the next page. So for number 3, we're going to do the line equals x. Now y equals x, although it is not a, it might not be tested, the line y equals x is just all the points that follow the rule where y and x are equal. So the point 0, 0, 1, 1, 2, 2, 3, 3. All the points on that line right there, okay, or -1, -1, -2, -2, and so on and so forth. And so the rule for this, we'll start with the rule first because it's hard to kind of experiment here, but would be, well, let's take a look at point C, right? It has to be the same distance on the other side. So C is kind of down 1 over 1 to the line. So if I repeated that, I would get a point that's located right there, which is where its image would be. And so this is C prime. So we can see the point, right? A is going to have some coordinate, and A prime is going to have some coordinate. We'll get there in a second. Okay, and then B is going to have something, and B prime is going to be something, and then we have point C, which is the point 2, 4, and we can see that C prime became the point 4, 2. And so what happened, right? The X and Y coordinates switched. Okay, so the general rule, R and the line Y equals X of the point XY becomes the point YX. So A, which looks like it's 1, 2, 3, 4, -5, and then 1, 2, 3, 4, 5, 6, 7, 8 is going to become the point 8, -5. Okay, so 2, 4, 6, 8, 1, 2, 3, 4, 5, and that's where that point's going to go. All right, and then point B, which is the point, looks like it's -4, 3, -4, 3 is going to become 3, -4. So 3, -4, and there we go. Now remember, we should get something that is congruent, right, to the original shape. So if you get something and the shape is just off, like this doesn't look like it's the same size or same shape, then that probably means we did something wrong, okay? The only transformation that is not going to produce a congruent shape is going to be a dilation that changes the size, all right? And what happens if it's not if you're not reflecting in the y-axis or the x-axis, but it's still a vertical or horizontal line? Well, we still follow the same rule we did earlier. So first of all, we want to reflect over line x equals 2. So let's draw that line first. So x equals 2 is a vertical line that goes through 2 on the x-axis. And we're going to follow the same rule we just did, okay? Which is, I'm going to count to the line, okay? And so this point is 1, 2, 3, 4, 5 units away from the line x equals 2. So we're going to go 1, 2, 3, 4, 5 units across. And there's A, okay? Now B, remember A was on the left, so it moved to the right of the line. B is on the left, so it's going to move over to the right, right? 1, 2, 3, 4, and we're going to go 4 across, and there's where B is. Okay, but C started on the right, so it's going to finish on the left side of the line, on the other side. Okay, so that's how we're going to move across on our lines. We're going to draw, we can switch colors here. Then we're going to connect our points back together with an end of the triangle. Remember, it should look congruent. Okay, so there's same size, same shape. There's A prime. Okay, B prime went over here, and C prime went over there. So the coordinates again, A has coordinates, looks like -3, 9. B has coordinates -2, 4. Remember, we're reading these points back from 0, 0. So I'm always going back here, right? Not using this point right here where the x equals 2 is, but going back to the origin. So it's -2, 4, -3, 9, right? And C was here. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so that's how we make sure we're reading the points using the origin as our counting point here. So A prime, there isn't really a rule for this, So just keep that in mind. So I guess you could say it like reflected over the line, so it's like add 2 to the whatever number it was, but it's 1, 2, 3, 4, 5, 6, 7. So you kind of add 4 there, and then 1, and then 9 again. So the x value is changing. The y coordinate is going to stay the same, right? B prime, it became the point 2, 3, 4, 5, 6, 4, 6, 4. And then C prime became the point -2, 5. All right. So now what happens if we reflect over the line y equals -1? So we'll do this one in red. Remember, y equals crosses through the y-axis. So this is the line. Y equals -1. Remember, this was x. Do it again. This was x equals 2. Okay. And this is y equals -1. All right, so same rule apply though. Count from the line, from the point to my line. That starts above, it's going to finish below. So it's 5 to the line, and then 5 past. So there's B prime, okay. A is 10, 9, 1, 2, 3, 4, 5, 6, 8, 9, 10, 1, 2, 3, 4, 6, 7, 8, 9. Uh-oh, we're doing it again. We went off the graph. That's a no-no, right? Ooh, but we can't, once again, that's a Mr. Z error, okay? So, because we should have given you the graph already, we can't change the coordinates. So we got to be careful. That's my bad, all right? But that's where the point's going to go. We'll still remember the coordinates. And then C is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Normally, if a question was going to have you graph and it was going to go off the graph, they would not have provided the points. They would have just given you the coordinates. So you would need to then come up with the scale on your own. Okay, so B was down here now. A is down here, and then C is over here. So C prime, I should say. So we know A already started with the point -3, 9. So I'm not going to do this again. Now we're going to use 2 primes here instead of 1 because we already have an A prime. So this is A double prime, B double prime, and C double prime, indicating it's the second transformation. Okay. And then this coordinate here is going to be the same x coordinate. So it's -3 again, is what we started with. But now the y coordinate is changing. So this should be -11. All right. B double prime is going to be -2. And then 1, 2, 3, 4, 5, 6, -6. And then C double prime is going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So 6, -7. Nope, that's 4, -7. 4, -7. Okay. And so for number 5, just y equals x again. So remember the rule, right? We know that the point xy is just going to become the point yx. All right. So we want to graph A prime, B prime, C prime, which is the image of ABC, and state the coordinates. So there's 2 ways to do this. So in general, you can write down your coordinates first. So we're going to write ABC. We're going to write the original, right? At this point, we're going to say A is right on that there. So we're going to read those coordinates as right on. Same thing here, okay? And same thing there. So those are going to be the coordinates of ABC. So we're going to go 1, 2, 3. So B is going to be 3, 1. Okay. C is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 10, -2. And A is going to be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 4, negative 6. And so now I know that with my points, I just have to switch them. So it's negative 6, 4. B prime becomes the point 1, 3, and C prime becomes the point negative 2, 10. All right. And so now I'm going to go graph 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So there's the first point. 1, 3 is the second one. All right. And the last one is negative 2 and up to 10. And we're going to get this guy right here. And let's go same color. Okay, so once again, this should look congruent to the one that was there. And just looks like it flipped over, right? That mirror, essentially, which it does. Okay, so just keeping that in mind. So we know A is the point for negative 6, 4. So here's A prime. B prime was 1, 3. And then C prime was all the way up. Now, when we do the next part, when we do rotations, okay, we're going to kind of notice here that when you did a reflection, remember that the points are like mirror images. So if I were to swing on a rotation and turn this figure, okay, then point C should end up where A is, and A should end up where C is. So how you tell the difference between a rotation and a reflection is to take a look at the coordinates. So in a rotation, okay, we're rotating around a single point called the center of rotation, okay, and the orientation is going to stay the same, and the size and shape are going to stay the same. So this is going to be a rigid motion that preserves orientation, and unless we're told otherwise, we're going to be rotating with multiples of 90. So 90, 180, 270, 360. So there's two ways to do this on your graph, okay? All right, and the first way is to, we'll do Miss Yostros's method, which is swap and op. Okay, so what I'm going to do is I'm going to record the coordinates, all right, for each of the points, and I'm going to do a swap and op. I'm going to switch their spots and then change the first number after I swap them. Okay, so point A, right, I can see has the coordinates 1, 2, 3, 4, 5, 6, 7, 8. So 1, 8. So that means I'm going to swap them. Okay, I'm going to go lower. So A prime is swapped is going to be 8, 1, and then I change the sign of the first number, so it's negative 8, 1. All right, B has coordinates, looks like 2, 2. So I swap them, stays 2, 2, and then I switch the first number. So B prime is going to be negative 2, 2. And then C has coordinates of 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 5. So I swap them and change the first number so it's negative 5, 6. Now I have to do the swap and op for every 90 degrees. Okay. The second option is actually to turn my paper, to actually rotate my paper. Okay. So watch. I'm going to take my paper, I'm going to take my graph, and every 90-degree rotation, every positive 90 degrees I'm going to rotate, or counterclockwise, right? So think about a clock. Clock's turned to the right. That's a negative rotation. Okay, we want to turn ours to the left against the way the clock moves, so counterclockwise. All right, and so just so we see, right, here's our clock. Right, so the clock always turns this way. So this is clockwise. This is going to be a negative rotation. Okay, positive rotations turn against the clock, so they turn to the left. So what I'm going to do is I'm going to take my paper. Okay, you guys ready? Do it with me. Take your paper and turn it to the left one time. Okay, so if you spun your paper, right, and actually, if you spun your paper, it would have done something like this if you turned it to the left one time. Okay. Now what we're going to do is we're going to pretend that this is our normal graph now. All right. So I'm just going to go back and turn my one graph, but we'll leave it here. So you turned your paper. Now it looks like mine. Okay. Now it looks like mine. So best fit, right? Looks like this, okay? So we turned it one turn to the left. Now we're going to go read our graph just like normal. So here's my y-axis if this is a normal graph, and here's the x-axis. So after I turn it, this is what the graph looks like when I'm done turning it. So this is the answer. So what I need to do is read these points. So this is the point 1, 2, 3, 4, 5, 6, 7, 8. This is -8, 1. And so what I'm going to do is I'm going to turn my paper back to normal, right? Turn my paper back to normal, okay? And I'm going to go graph the point -8, 1, okay? So I go back. I'm going to graph -8, 1. So just trying to find the y-axis on here. So -8, 2, 3, 4, 5, 6, 7, 8, 1, and there's where A prime goes. And then I'm going to repeat that now, repeat that process now. So we're going to take my graph, we're going to turn it one turn to the left, right? Turn to the left, boop, okay. And then I'm going to read my graph. So remember, that's where that went. I'm going to read my graph just like normal, okay? So point B would be -2, 2, -2, 2, right? Because that's the answer. So then I turn it back to normal, okay? And I'm going to go graph -2, 2. Do we want to kind of make this flush again? So go graph -2, 2. All right. And then I do the same thing again for C, right? I turn my graph, okay? I read it. So C is the point going from X and Y, from 0, 0 again. So 1, 2, 3, 4, 5. -5, 1, 2, 3, 4, 5, 6, -5, 6. So you can either turn your paper, right, read the points, turn it back to normal, and then graph them. Totally cool. All right, I'll leave that up to you. Or we are going to this was, yeah, -8, 1, 2, 2. Or you got to do the swap and op, okay? So it's your call. 1, 2, 3, 4, 5. And there we are. And then I go ahead and draw my line in. And so once again, right, this graph looks the same. So it's just turned. It's just taking this and turning it this direction. So point B is going to move down here. Point A actually goes all the way over to here. There's A prime. Okay, and point C shifts to there. There's C prime. And there's my new graph. All right. And so what actually happened, right, is that when we did, now a rotation gets a capital R for its notation. All right. And we're rotating it. And we want to write down two things. What's the center? So the center, once again, is the origin. So either O, or we can write down the point 0, 0, and then comma, and then the degree measure, 90 degrees. Okay. And so the rotation in the origin, rotating 90 degrees, took the point xy and turned it into the point -y, comma x. So that's the rule here. All right. So the same thing for 180, and I don't understand why this is here, but it is. So we'll make do. So write the rule for 180. So once again, for 180 degrees, we're going to take our graph. We can either spin it 2 turns to the left, which is going to actually make it go upside down, or we do swap and op twice. Your call. So let's take a look and let's do it XYZ. Oh, notice it says ABC. Nice. So XYZ, and then X prime, Y prime, Z prime. All right. So X is the coordinate 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the point 2, 9. And then since I'm doing 2 90-degree rotations, I need to do 2 swap and ops. This is going to become swap and op -9, 2. And if I do it again, swap and op, so I switch them and negate the first, is -2, -9. Right? So what actually happened is that to do my rotation, should I write lowercase r? my rotation, right, in the origin of 180 degrees, the point xy became the point negative x, negative y. So I just switched the signs, okay? So y is the point 3, 3, right? Swapping up is going to become the point negative 3, 3. And then when I do the swapping up again, this is going to be negative 3, negative 3. Okay? And point Z, we can read 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6 is the point negative 7, or sorry, positive 7, 6. So swap it up once, negative 6, 7. Swap it up again, negative 7, negative 6. We just change the signs. All right? And that is what happens when I do my rotation of 180 degrees. Okay, so the graph actually flips upside down. So negative 2, right? Negative 9 is down here. All right, we have the point negative 3, negative 3, and the point negative 7, 2, 3, 4, 2, 3, 6. And this is what our triangle looks like when we're done. All right, so it kind of looks like a reflection in a way, right? Except if I reflected it, x would travel here. That's how we can tell the difference between a reflection and rotation. And a rotation, when I turn it, actually moves to the other side over here. So z, it looks like it should be here, but it's actually over there. And then y is over here, okay? So keep in mind, you're going to tell the difference between a reflection and a rotation by the order of the points. Okay, so 270 is a rule. So once again, that's 3 moves. So we can either turn our graph 3 times, okay? Turn our graph 3 times. So if we turn it 3 times, this would be 1. I'm gonna just make this a little bit smaller here so we can see it better. This would be 1 turn to the left. That's 90. 2 turns to the left is 180. And 3 turns to the left is 270. Okay, so if I was looking at the graph like this, what I would say was, we're going to read it just like normal, okay? So if my normal graph, I would write down the coordinates. So E is the point 1, 2, 3, 4. 1, 2, 3, 4, 5. This is 4, negative 5. That's the answer. So E prime is 4, negative 5. D prime is going to be 10, negative 4. And F prime is going to be negative 6, negative 9. So that's how we do the rotation, just turning our paper. Okay, we're going to turn back to normal though, and we'll do the swapping out method, since I feel like you guys are going to be more familiar with that. So we write down the coordinates. So that's D is the first one. Okay, and we're going to do 3 swapping ups. So 1, 2, 3, 4, 5. Sorry, 4, and then 10. So 3 swapping ups is going to be negative 10, 4. Swapping up again is negative 4, negative 10, and swap it up one more time. Remember, it started with swapping and opping, so it's supposed to be negative 10. We're going to opt that though, so it's positive 10 and then negative 4. Okay, so what actually happened again? The rotation about the origin, this time of 270 degrees. Okay, turn the point xy into the point y, negative x. So actually, this is kind of an op and swap instead of a swap and op. Kind of interesting. So E, right, which was the point, counting 1, 2, 3, 4, 5, 4. Now, if we remember just instead of swap and op, it's op and swap. This should end up being, right, the point 4, negative 5. Op and swap. But we'll get there. So swap and op is going to be negative 4, 5. Okay, and then swapping up again is going to be negative 5, negative 4, and then swapping up again would be 4, negative 5, which is correct. And then F, which starts as the point 9, 1, 2, 3, 4, 5, 6. So this is 9, 6. So swapping up is negative 6, 9. Swapping up again is -9, -6. And then swapping up again is going to become, instead of -6, is +6, -9, which is up, and then swap. So perfect. I'm just going to fix that 9. Okay. So might have been better the first time. So there we go. So we're going to graph those points for ourselves, and then we can just go ahead and draw in here. So 10, -4, right? 4, -5, and then 6, -9. All right. And really, this just looks like a 90-degree rotation, but remember, we're turning to the right instead of turning to the left. So that's what a 270 is. And there's our triangle, right? So E prime is over here, D prime is over there, and there's F prime. And we're good to go. All right, so we're going to do 2 moves on this one. This is the last question. So see if you guys can do this on your own. We'll go over each one. So try A first, graph and label the original. Go ahead and graph and label the image after a rotation of 90. And then we'll take a look at the answer first, and then I'll have you guys do C. So go ahead and graph the first one. And so there's ABC. All right, so go ahead and do your rotation of 90, and make sure you graph it and state what the new coordinates are, okay? All right, so go here is your rotation of 90. So remember, spinning to the left. So A prime, B prime, C prime, which coordinates? -2, 1, -5, 0, and -4, 5. So remember, swap, and then opt the first one, okay? All right, go ahead and take those coordinates, so what we just finished, the red triangle, and go ahead and reflect that over the x-axis. Okay, go ahead and do that now. Remember, we're reflecting the red triangle, A prime, B prime, C prime, over the x-axis. Okay, so this is the triangle after we do the reflection. Remember, the rule is that we are going to switch the other letter. So we're reflecting the x, we change the y. This should be -2, -1. Okay, so B double prime should be -5. We don't have the y coordinate is 0, so it should stay there 0. And then C double prime should be -4. Switch the y, -5. And there is our last question of the day. All right, that's it, guys. One more day of learning, some review, and then we're going to do, well, the week after is going to be a little makeup week, just to get caught up on your work. All right, guys, have a great day.